This lesson is the Moivre theorem. Again, it is called the Moivre theorem. So here we are going to convert complex number in polar form. Okay, so here I have, this is what complex number looks like. We're going to change this into polar form. So again, complex number. Okay, this is complex number and this is in rectangular form. So this is your x, square root 3. Your y is -1. Okay, and where is this square root 3 minus I located? Okay, so here's your x, here's your y. When you graph complex number, x is considered the real, y is considered the imaginary. Okay, x is the real, y is the imaginary. So square root 3, somewhere right here between 1 and 2, close to 2. Okay, -1 is right here. So this is the location of square root 3 minus I. Okay, again, x is your real, y is your imaginary. This is complex number. This is in rectangular form. So let's find out r. R is x squared y squared, the whole thing square root. So square root 3 squared is just 3. -1 squared is just +1. 3 plus 1 is 4. Square root 4 is 2. So r is 2. Now find the theta or angle. Again, when you find the angle, it is always you always use tangent. Okay, always use tangent to find the angle. And we know that it is y over x. Y is -1. Square root 3 is your x. Bring tangent over, which become the inverse. Put this in your calculator, and it will come out to be -30. Okay, again, put this in your calculator, and it's going to be -30. So just to show you that it is -30, so here we go. So turn this on, make sure tangent inverse, so second. So here's your second, tangent. So there it is, tangent inverse. Put the -1 in, and be careful your calculator. Sometimes there's two negative. This is for subtract, this is the negative. This is the subtract, this is the negative. So press that button, there's the negative. Put the 1 in, okay, and now divide square root 3. Divide square root, so square root is right here. So second, this button, so that's where the square root. Put the 3 in. Okay, now close the parentheses and then close it again. Okay, make sure it is in degree mode right here. It says right here, degree mode. Make sure it is in degree mode. Okay, and then press enter, and there it is, -30. Okay, and that's where the -30 comes from. Okay, however, according to the graph, this is in quadrant 4. This is in quadrant 4. We don't want negative degree, we want positive degree. So 360 subtract 30 is 330. So -30 is the same as positive 330 degrees. Okay, again, why do we do this? Because it is in 4th quadrant. Okay, we don't want negative degree, we want positive degree. Okay, and this is how we rewrite it in polar equation. So this is rectangular, this is your x, this is your y. This is how you write polar. R go in front, R go in front, cos 330 plus I sine 330. And this is the format, this is the order that it goes. Cos first and then sine. R always go outside. R outside, cos 330 plus I sine 330. Okay, so this is the order. R is outside, cos, and then I sine. Put the degree in. Okay, rectangular, complex number or form, polar form, same location. Okay, and same thing. Okay, same location, same graph as well too. Okay, So be very careful. Rectangular, polar. Okay, rectangular for complex number, polar for complex number. They are the same thing, same location, and same graph. Okay, now let's reverse this. So we went from rectangular to polar, now polar to rectangular. Okay, so here is the equation, the example of polar complex number. Okay, all we have to do is find what is cos 30, so use your chart. Same thing, what is sine 30, use your chart. Okay, make sure you use your chart. Okay, so cos 30 is square root 3 over 2. Sine 30 is 1 over 2. Do not forget the I. Do not forget the I. Okay, now just multiply, distribute. 2 times square root 3 over 2. 2's cancel, so square root 3. Distribute the 2 out. Distribute the 2, so 2 cancel. I just have I. So this is the answer in rectangular form. This is the answer for polar form. Complex polar form, rectangular form for complex. Okay, so that is the reverse. So this example is for rectangular to polar. This is polar to rectangular. Okay, now we want to multiply and divide complex in polar form. So here's an example for polar form, and here's another example for polar form. We want to multiply these two together. Okay, so very easy. 3 times 5, there's 3 times 5. First degree, second degree, just add them up. When you divide, just add up the degree. First degree, second degree. So 20 plus 100, 120. Same thing with over here, 120. So this is how you multiply polar complex form. Okay, the number outside, multiply. The degree inside, you add. Okay, now divide is just opposite of it, it's just divide. Okay, so 3 divide 5, so 3 divide 5. In division, we subtract, so 20 subtract 100. Okay, 20 subtract 100. Same thing over here. So 20 subtract 100 is 80. 20 subtract 100 is negative 80. Okay, but we don't want the negative degree. We want positive degree. So 360 subtract 80 gives me 280 degrees. Okay, so again, we don't want negative degrees. We want positive degrees. Okay, so 360 subtract 80 gives me 280 degrees. So this is for dividing complex in polar form. This is for multiplying complex in polar form. Okay, so this is the first part of complex polar form, okay, in the Moivre theorem.